Good morning, students. I'm Teacher Johaima, your teacher in Mathematics 9. Are you now ready to have some fun and learn in mathematics? But before that, let us have a warm up.
It's time to practice math. Practice math. Hip hop math. Hip hop math.
Multiplying and dividing makes me glad.
Hip hop math. Hip hop math.
Multiplying and dividing, it makes me glad. Stacking chips, 6 times 6. What does that give me? 36. 8 times 4. What is the score? Don't know about you. It equals 32. 4 times 3, that equals 12. Just like my money, it's doing well. 5 times 5, that's 25. Crunching numbers in my head before I go to bed.
Hip hop math. Hip hop math.
Multiplying and dividing makes me glad.
Hip hop math. Hip hop math.
Multiplying and dividing, it makes me glad. I'm not scared of the test. My math is the best. Tally up the answer sheet and A is what you're giving me. The universal language, even in space. I handle math with plenty of grace.
Hip hop math. Hip hop math.
Multiplying and dividing makes me glad.
Hip hop math. Hip hop math.
Multiplying and dividing, it makes me glad.
Did you enjoy our warm up for today? Me too. But what is the relation of this warm up in our lesson? Yes, the operations multiplication and division. We will use them in dealing with our topics for today, which is the law of signs. But before we tackle our lesson for today, let me ask you a question first. What formulas did you use to solve the right triangle? Yes, the Pythagorean theorem. Another, the SOHCAHTOA or the primary trigonometric ratios. And the last one, all angles add up to 180 degrees in a triangle. Very good. Now, can you use those formulas in this triangle? The answer is no. But why? Because Pythagorean theorem and the SOHCAHTOA are only meant for right triangle. And this triangle is not a right triangle. And the third one, we can only use that one if the given are two angles. But in this problem, the given is only one angle. And this triangle is what we call an oblique triangle. An oblique triangle is any non-right triangle. So what is the meaning of non-right triangle? Meaning there is no one right angle. There are formulas to solve oblique triangles, just like there are four right triangles. You have learned to solve right triangles in our previous lesson. Now, we will solve oblique triangles, or what we call the non-right triangles. But take note, angles are capital letters, and the side opposite is the same letter in lowercase, just like this oblique triangle. So in this oblique triangle, angle A and its opposite side is side A, which is written in lowercase. And this is angle B. Its opposite side is side B. And angle C, its opposite side is C. So we will also discuss about adjacent side. So adjacent means next to or adjoining with the same something else. For example, angle B. Its adjacent sides are side A and side C, while angle A, its adjacent sides are side B and side C. In angle C, the adjacent sides are side B and side A. We have also what we call the included side or included angle. For example, in angle A and angle C, the included side is side B. When we're talking about angle, in side B and side C, the included angle is angle A. These were the things that we already know about oblique triangles. The first one, the interior angles total is 180 degrees, meaning if we add angle A, angle B, and angle C, we will get 180 degrees in total. The second one, we cannot use the Pythagorean theorem. Why not? Because Pythagorean theorem is only meant for right triangles. You must remember these things. Let us now discuss our topic for today, which is the law of sines. The law of sines helps you solve for sides or angles in an oblique triangle using this formula. Side A over sine A is equal to side B over sine B is equal to side C over sine C. You can also use it upside down, just like this one. So sine A over side A is equal to sine B over side B is equal to sine C over side C. But not all the time you can use law of sines in solving oblique triangle. There are things you must remember. You can use law of sines when you have at least 3 parts of a triangle and you need to find the other 3 parts. But they cannot be just any 3 dimensions though, or you won't have enough input to solve the law of sines equations. Use the law of sines if you are given the following. The first one, the AAS, or 2 angles and 1 adjacent side. The second one, ASA, 2 angles and their included side. So, these were only the given that you can use the law of sines. We also have general process for law of sines to follow. The first one, except for the ASA triangle, you will always have enough information for one full fraction and half of another. Start with that to find a fourth piece of data. The second one, once you know 2 angles, you can subtract from 180 to find the third. The third one, to avoid rounding error, use given data instead of computed data whenever possible. So you must remember these 3 in processing your law of sines. Since we already discussed the general process for law of sines, let us now have example number 1. So solve this triangle. So in solving this triangle, first you need to look for the given. So in this triangle, there are 2 angles given, the angle A and the angle B, and one adjacent sides, the side A. So this is what we call the AAS. So the two angles and one adjacent side. So in this triangle, since the two angles are given, we can now solve for the third by using this one. The measure of angles in a triangle has a total of 180 degrees. So solve for angle C. So for solving angle C, just add angle A to angle B, and then we will get the total of, yes, 150 degrees. So after we get 150 degrees, subtract it to 180 degrees. So 180 degrees minus 150 degrees, the value of angle C now is, very good, it is 30 degrees. Next step, set up the law of sines to find side B. So in finding side B, we can use the full fraction of side A and angle A. So our equation will be side A over sine A is equal to B over sine B. So if we will substitute the values, we will get 12 over sine 70 degrees is equal to, since the unknown is B, we will just rewrite B over sine 80 degrees. So by cross multiplication, we will get 12 times sine 80 degrees is equal to B times sine 70 degrees. Next step is to divide both sides by sine 70 degrees so that B will remain by itself. So we will get B is equal to 12 times sine 80 degrees all over sine 70 degrees. So if we will use our scientific calculator, we will get an approximately of 12.6 centimeter value if we will round up the value by nearest tens. So our value for side B is 12.6 centimeter. To solve for the value of side C, again, set up the law of sines to find side C. So our equation will be side A over sine A is equal to C over sine C, which is 30 degrees. So if we will substitute the values, we will get 12 over sine 70 degrees is equal to, rewrite C, over sine 30 degrees. So by cross multiplication again, so 12 times sine 30 degrees is equal to C times 70 degrees. So divide both sides again by sine 70 degrees. We will get C is equal to 12 times sine 30 degrees all over sine 70 degrees. So again, we will round up our answer. We will get an approximately value of 6.4 centimeter. So the value of side C is 6.4 centimeter. Another example of AAS, the two angles and one adjacent sides. So this is our values. So angle A is 45 degrees, angle B is 50 degrees, and side A is equal to 30. So first, we will solve for the value of angle C. So by mentally solving, what is the value of C? Very good. It is 85 degrees. You're given both pieces of sine A over A and part of sine B over B. So we start there. So sine 45, which is the value of angle A, over 30, which is the value of side A, is equal to sine 50, which is the value of B, over the unknown, which is P. Next step, cross multiplication, we will get B times sine 45 degrees is equal to 30 times sine 50 degrees. Next, divide both sides by sine 45 degrees. So we will get B is equal to 30 times sine 50 all over sine 45. So we will get, good job, it is 32.5. Next, sine A over A is equal to sine C over C. So this is an equation to solve for the value of C. And then substitute the values. So sine 45 over 30 is equal to sine 85 over C. So C is our unknown, the side C. Next, cross multiplication. We will get C times sine 45 is equal to 30 times sine 85, and then divide both sides by sine 45. We will get C is equal to 30 times sine 85 all over sine 45. So what is the value of C now? Good job! It is 42.3. Very good. Let us now move to example number 3. So solve this triangle. Look at this triangle. Look at the given. So the given are two angles also and one side. But this side is in between of these two angles. So it is an included side. So this problem is an example of ASA, the two angles and one included side. Since we cannot start one of the fractions, we will start by finding the value of angle C. So by mentally solving, what is the value of angle C? Very good. It is 135 degrees. Since the angles were exact, this is not a rounded value. We can use sine C over C as our starting fraction. So this will be our equation. For side A, we will use this one. For side B, we will use the second one. So for side A, the equation is sine C over side C is equal to sine A over side A. For side B, the equation is sine C over side C is equal to sine B over side B. Substitute the value, we will get sine 135 over 45 is equal to sine 35 over A. Next, cross multiplication. We will get A times sine 135 is equal to 45 times sine 35. And then the next step, divide both sides by sine 135. So we will get A is equal to 45 times sine 35 all over sine 135. So using your calculator, your scientific calculator, what is the value of our A to the nearest tens? Very good. It is 36.5. Next, for the value of B, substitute the values. Sine 135 over 45 is equal to sine 10 over B. Cross multiplication, B times sine 135 is equal to 45 times sine 10. Next, divide both sides by sine 135. We will get B is equal to 45 times sine 10 all over sine 135. So again, using your scientific calculator, what is the value of our B? Good job! It is 11.1. So now you better understand our lesson for today. What if our problem is like this one? It is only the given. There's no figure. So it's up to you if you want to draw a figure and put the given so that you cannot get confused in solving for the unknown. But if you know how to solve for the unknown without the figure, much better. So in this problem, the unknown is angle C and side C. So to solve for angle C again, so we will subtract the value of A and B to 180 degrees. Okay, so the value of C, angle C, is equal to, yes, it is 122.5 degrees. Since the value of our angle A is now available, we can now solve for the value of side C. So by using the equation in law of sines, we will get C is equal to sine 122.5 degrees is equal to 8 over sine 36 degrees. So by simplifying this one, we will get C is equal to 8 times sine 122.5 degrees all over sine 36 degrees. So using your scientific calculator, what is the value of our C? Good job. It is 11.48 if we will round up this one into nearest hundreds. But it's up to you if you want to round it off to nearest tens. Your answer will be 11.5. Now, let us have a recap on our topic for today. So, the law of sines help you solve for sides or angle in an oblique triangle. So, these were the equation. You can also use it upside down, just like this one. Use law of sines when at least you have three parts of a triangle and you need to find the other three parts. But they cannot be just any three dimensions though, or you won't have enough info to solve the law of sines equation. You can use the law of sines if you are given. First, AAS, or the two angles and one adjacent side, and ASA, the two angles and their included side. For general process for law of sines, we have three. Except for the ASA triangle, you will always have enough information for one full fraction and half of another. Start with that to find a fourth piece of data. Once you know two angles, you can subtract from 180 to find the third. And last, to avoid rounding error, use given data instead of computed data whenever possible. And for your assignment, solve this triangle. I will wait for your answer. Pass it on Wednesday. Hope you enjoy and learn a lot today. I just want to share you this message. Math may not teach us how to add love or subtract hate, but it gives us hope that every problem has a solution. This is Ma'am Johaima, your teacher in Mathematics 9. Thank you and God bless.